case you didn't know, you're actually able to create your own cryptocurrency or custom token on top of the Ethereum blockchain through the use of smart contracts. You might have also heard about the hype and the craziness surrounding these so-called ICOs, or initial coin offerings. And all initial coin offering is a crowd sale put on by various companies, usually tech companies, to exchange their custom tokens for Ether as a way of raising capital. Now, some of these things have gotten quite out of hand because they're actually quite popular usually, and they end up sometimes crashing the entire Ethereum network. In this video, I'm actually going to show you how to create your own custom token, and then in a following video, I will show you how to create your own ICO contract so you could raise funding for any of your own projects in the future. So to get started, let's take a look at what is called the ERC20 token standard. And all the ERC20 standard is a draft specification created in 2015 that defines what a token contract should look like. And virtually all of the modern custom tokens that have been put out in the last few months all follow this standard. So every token should have a total supply function, and all that does is return the total amount of tokens in circulation. It should have a balance of function, and given an address, it returns the balance that address holds of your token. A transfer function does exactly what you would expect it to do. It would transfer the value to another address from your own address. Transfer from is a special type of transfer, and basically, as I will talk about down below, you can give permission to another address to spend tokens on your behalf. So this is what this transfer from function is for. And then this approve function basically lets you give permission to another address to spend on your behalf. And then the allowance is just a function that returns how many tokens you've given permission to that other address to spend. And then the final two pieces are these events, a transfer event, an approval event, and they're just a way to log what's going on. So if a transfer happened, you log to, you're transferring from, to, and then the value, and then the approval. Basically, you're logging that you've given permission for an address to spend on your behalf. Now, before we dive into any code, in order to work with the contract that we're about to create, you're going to need to install a Chrome extension called MetaMask. And all MetaMask is an Ethereum wallet that runs within the Chrome browser and allows you to actually interact with Ethereum decentralized applications by injecting a JavaScript library called Web3 into the browser. And by doing that, any Ethereum connected web application will use that library in order to talk to the Ethereum network and then do its thing. You're also able to connect to a local Ethereum network that's running on your own computer, as well as several Ethereum test networks. So once you have that installed, it's going to ask you for a password, and then it's going to generate a wallet for you. And then you're going to see something like this. So you'll see your account, and then how much Ether you have, and then any transactions. And also up here, you're able to select the network. So you can run on the main Ethereum network or any of these test networks, or if you have a client, an Ethereum client running on your local machine, you can actually connect to that. In this case, we're going to run on the Ropsten test network, which is a live network that actually has to be mined in order for transactions to run through. So it's as close to running on the main Ethereum network as we can get without actually having to spend a bunch of money. So go ahead and get that installed before you continue on to the next part. So coming into our Remix IDE, I've basically copied all of those methods from the proposal and created an interface called ERC20. And then I've created a contract that imports that file and then implements that interface. So we actually have to implement these functions because this token contract doesn't do anything. So we've got this func token, and basically the first thing we're going to do is implement this total supply function. So we're going to need to return a total number of func tokens in circulation. So we can do that first by creating a variable, making it public and constant, and then calling it, we'll just call it total supply, and we're just going to say, how about 1 million? So 1 million func tokens. And then we're also going to send this initial balance to ourselves. So we're going to say, we're going to need this a place to actually store these balances. So let's create a mapping. And it's going to be a mapping from address to an unsigned integer of 256. We're going to call that balances. And the first balance we're going to initialize is our own. So we've set the total supply to our balance, and we're also going to return the total supply in that function. So that function is taken care of. The next thing we want to do is return the balance of an address, and that's easy. So all we have to do is return balances, and then given an address, which in this case is _owner, return that. So that takes care of that function. The next is transfer. So this is a little tricky in that we need to do some checks before we actually are able to transfer anything. So to run the check, we're going to use a require statement. And a require statement is basically an if statement in shorthand that will throw an exception if any of the conditions inside it fail. So we're going to do multiple conditions. The first condition, we're going to check to make sure that whatever we're trying to transfer out actually exists in our balances. So the balance of message.sender needs to be greater than or equal to the value we're trying to send. And then the next thing we're going to check for is to make sure that value is greater than 0. We're not going to try and waste time sending 0 to somebody. So if those two pass, we can go ahead and transfer. And the way we do that is we decrement the balance of the sender, and then we add to the balance of whoever we're transferring it to. And then the next thing we're going to do is log that this happened using the transfer event. And just looking down below, the transfer event will take a from, so it'd be from message.sender to, and then the value. Because this needs to return a Boolean, we'll return true because it succeeded. So that takes care of the transfer function. Next is the transfer from. This is also going to require some checks. And one other thing we're going to need to create is some way to track who's been given permission by who to transfer on their behalf. So to do that, we're going to create another mapping. And this is a mapping of an address. So this first address is who is giving permission. And then we're going to map it to another mapping. And inside that mapping, there's going to be an address. And this address is who is being given permission to spend these funds. And then that's going to be mapped to how much they're actually allowed to spend. And we're just going to call that allowed. So back down here in this transfer from, first thing we're going to check is that whoever is trying to spend this, that they're actually allowed to do that. So we're going to check that allowed from, so they're trying to spend this person's tokens. And then we're going to check to make sure that they themselves, so message.sender, are able to spend this much, so greater than or equal to that value. We're also going to check, just like in the previous function, that the balance of whoever we're trying to spend from is greater than or equal to the value. Also, we don't want to spend any zero balances or send 0 tokens. So we're going to check that value is greater than 0. So if all those pass, we'll go ahead and do the same thing that we did above. We'll transfer, so from, we'll take away the value, and then we'll add to the recipient, which is 2. And then one last thing we need to do, because in this next function, we're going to allow someone to spend a certain amount. We're going to have to decrement from that amount. So if they spent 50 of like 100 tokens, we want only 50 to be left in the allowed mapping for them to spend later on. So allowed from message.sender, and we decrement that value. And then we log another transfer event. So from to value, and return true because it succeeded. So next we have this approve function, and this is pretty simple. All we do is add, update the value in the approved mapping up above. So approved message.sender for the spender, and they're able to spend this much of our tokens. Undeclared. Oh, allowed. So they're allowed to spend that many. And then we return true. Oh, one thing we also need to do is log that we've given an approval, so we can track that later. So message.sender spender and then value. And then this last function is just going to return the value from that allowed mapping. So and that's basically it for the contract. We've implemented everything in that interface, but there are a few more things that need to be added in order to make it a more user-friendly experience when people are actually working with your tokens. So there are a few more variables that most of these tokens actually define. So the first one is going to be a string, and that is called symbol. So if your token actually ends up on an exchange like Poloniex or Bittrex, it's going to be trading under a specific symbol. So you're going to want to try and pick a unique symbol. In this case, we're just going to use funk. And that's going to be our symbol. The next variable is going to be called the name, and that's just a special name. So funk token, and then finally this one is called decimals, and all decimals is a way to show how your tokens can be broken up or denominated. So in this case, we're going to use 3 decimal places, and because we have, let's say, 1 million funk tokens, this is actually how it's going to show up within your wallet. So essentially, 1 funk token is .001, and 1 whole number would be called something else. So just like in Ethereum, 1 ether is actually many times 1 way. 1 way is 1 quintillionth of an ether. So this would probably be called a super funk or a mega funk or whatever we want to call it. So that's how that's going to look when we actually open it up in one of our wallets. So everything is looking okay. Let's go ahead and try to deploy this. So when you're deploying on a live network, even a test network, it's going to run through your wallet. So your MetaMask wallet is actually going to ask you to accept the transaction, because it actually costs Ether to deploy contracts. So we're going to click accept because this is not real money. And then we're going to wait for this to be mined. Actually, through the magic of the internet, we're going to fast forward so you don't have to sit here and wait for this. Okay, so our contract has been deployed. Let's go ahead and copy this address. And let's head over to wallet.ethereum.org. And this, if you're familiar with the Mist Ethereum browser, this is the same interface. So you're able to run this through any browser as long as you have something injecting the Web3 JavaScript library into it in order for it to talk to the Ethereum network. So that's what we're using MetaMask for. So when you get to this main dashboard, we're going to click on Contracts and then go down to Watch Token. And we're going to paste our address. And for some reason, this is being finicky, so we're going to refresh this. Go back to Contracts. Try and paste it again. All right, it worked. So you paste this address and it found our token. It knows the name, it knows the symbol, and it knows the number of decimal places. So let's go ahead and hit OK. And now we're watching this. If we go back to wallets and click on our wallet, you can actually see that we have 1 million Funk tokens in our balance. We can also add this to MetaMask. This is an old contract that I was playing around with, so let's do the same. Add that, and now you can see it's in MetaMask. So both of these wallets know how to work with ERC20 tokens. And so we can actually test sending tokens to another address. I think I have a few addresses in MetaMask, so yeah. So account 1, account 2. We're going to copy the address for account 2, and then we're going to send. We're going to send to there, and then we're going to send 100. Now let's send 1,000. No, let's send. Well, let's send 10 Funk tokens. So that's what it's going to look like. Send 10 Funk tokens to that address. Hit OK. Accept. And then through the magic of the internet, we'll fast forward and I'll show you the balance of my other address. All right, now that the transactions have been mined, we've gone to this other address, and you can see we have essentially 10, I guess, super funks, mega funks, or 10,000 Funk tokens sent to this new address. And that's basically how easy it is to create your own custom token. In the next video, I'm basically going to show you some improvements on our existing contract, because in its current form, it's actually not very robust. There are some vulnerabilities that people have found with math. It's actually susceptible to what's called an overflow attack, so we'll go ahead and address that. And then we'll also describe how you would actually go about launching your own ICO, or initial coin offering, in order to raise funding for whatever project you desire. So if you like this video, please hit like. If you like what I'm doing, please hit subscribe so you can be notified of my new videos. And if you'd like to donate, I'd appreciate it. I've given all of my crypto addresses down in the comments below. I look forward to seeing you in the next video.